Question 9. Oh, I don't know why I fell in love with arctan, especially three arctans here. So this is just an arctan. So we would get 3 arctan of x evaluated from 0 to 1. So this would be like having 3 times the arctan of 1 minus the arctan of 0. Right, so you may not necessarily be well versed in your arctans. Like you may not look at this and like, oh, this is pi over 4 and this is 0 to get 3 pi over 4 as our answer. So just in case, just quick little like why that is the case. So the arctan of 1, I think something that a lot of students sometimes struggle with is what this actually means, right? So if I said something like with some space right here, if I select the tangent of pi over 4 is equal to 1, well, the arctan is the inverse of tangent. So if I were to take the arctan or the tan inverse of this side, I would have to do the same thing to the other side. So then, just like with all well-defined inverses, the arctan and the tan cancel out. We're left with pi over 4 is equal to the arctan of 1. So a good way to think about this is that the arctan and any arc function equals some angle. There's an x in there, right? So if I said, hey, the arctan of, say, radical 3 over 3, we would think to ourselves, which angle gives me a tangent of radical 3 over 3? Right, that would be pi over 3. So that would be, no, lies, pi over 6. Ooh, pi over 6. So that would be the value of your arctan. So arctans, arcsines, arccosines are also only defined in certain spots, right? So arctan only lives between negative pi over 2 and pi over 2. Right, so the value that you get for an arctan must land between those things. That would be the range of its function. The arcsine, I don't know why I just turned this into like a trig lesson. So the arcsine would only live between negative pi over 2 and pi over 2 inclusive. Right, so the first quadrant and like the negative first quadrant for both of these. And the arccos of x only lives between 0 and pi. Right, so any answer has to get between those values.